My name is Hisham Maturaka, and my project is about uh, PID controls and air conditioning system. PID control and air conditioning systems. Why am I interested in this project? As we know, PID control is widely used in any air conditioning applications. And air conditioning systems are used in all commercial and personal buildings. I'm always fascinated of how units work by transferring room space temperature from a cold to a hot one. And also I want to know how the PID control system communicates with the air conditioning unit. As we know, PID is been widely used in all our life, daily life. It use a calculation to measure variable and a set point. By doing that, the PID use a loop to perform proportional, integral, and derivative calculation to determine how aggressive to change an output, because we don't want a unit to overshoot, making the rooms either cold or hot. So one of the main goals of the PID control in an air conditioning system unit is to reach the system set point without destabilizing it. So work done in this subject. There were a lot of work has been done on the subject of PID and air conditioning system since the inventions of the system itself. And one of the major changes that has been done on the PID control to make the air conditioning system perform efficiently is the optimization of the PID control by changing its unit parameter in order to avoid state error and time response delays. So controlling the system use the PID to change the output of a mechanical equipment in order to maintain the set point target. So, for example, if the space is too cold, PID calculation control an actuator to open a hot water valve in the air conditioning system by increasing the discharge of air temperature to heat the space in a room place. So how the PID does its calculations? There are three major calculations done in PID. The first calculation is proportional, which has stronger effect on the result of the control system. The second one is the integral calculations, which responds to the length of time the measured variable is not at set point. So to regulate it, to bring it back to a set point target. And finally, the derivative calculation. The derivative calculation only responds to change in error. This is